Welcome to a lesson with Dr. Powell. Let's take a look at three interpretations of line integrals. Line integrals can be used to compute work, just as is a vector force field of some kind, and you're integrating along a curve. That's kind of like taking the force in the direction of the curve when you dot it with your dr along the curve. So you have distance times force really as you move along the curve. So a line integral quite literally can just be thought of as work done by a force field along a path. It can also be thought of as circulation. If v is like a velocity field and you want to know how much circulation you're getting around a loop, in particular c that you choose, that's induced by this velocity in the flow. And so then you call that amount the circulation. You can also think of a line integral that's in a closed loop as kind of keeping track of how much flow there is of a force field or a vector field of some kind that's passing through the region that's enclosed by the curve itself. So the way to do that, we don't want to measure how much is going along the path, but how much is going outward from the path, perhaps orthogonally pointing outward. The way we think about that is, let's suppose in our curve we have a dr here. Well, if we want the outward, imagine rotating this picture out this way, 90 degrees clockwise. You end up getting this picture with the y and the x pointing down, which gives you the sense that you have your dx that was pointing this way is now kind of taking the place of dy and it's negative, and the dy that was positive is now taking the place of the dy and it's pointing in the positive direction. So simply, if you just dot your force field with this, you end up getting the outward the outward bit of the vector field as you go around, and this idea is called flux. So basically a measure of how much force is passing out through from the inside to the outside of a particular curve that's enclosed. Of course, this is what we would use if we're going, if our curve is going counterclockwise. If we're going, if we choose to go clockwise this way, and we want to be representing this, since this vector is just the negative of what this one is, it just amounts to making just taking the negative of this if we're going clockwise. So, but in any case, we want to measure the same thing with flux, whether we integrate one way or the other. We just have to adjust the sign so we're really getting the right thing. Thanks for watching.